Dear students, class 10. Let's recap. In our last class, we discussed a linear equation in two variables, graphical representation, graphical expression. So the graphical expression of a linear equation in two variables is a straight line that we discussed in our last class. Today we have taken a topic from a textbook, that is pair of linear equations in two variables. Means we have taken two equations. Graphical method of solution. So we shall present a pair of linear equations in graph, in a graphical mode. So that what do we observe? Let's discuss. The first one, we have taken an example, x plus 3y minus 6. It is a linear equation. X plus 3y minus 6 is equal to 0. So, by transposition, y is equal to 6 minus x by 3. So, here actually look at the table. For any value of x, we get the value of y. So, 0, 2. So, these are two coordinates, x coordinate and y coordinate. A point on a plane is described by two coordinates, x coordinate and y coordinate. So, here x3, y1, x minus 3, y3, x minus 6, y4. So, this is the table meant for the linear equation x plus 3y minus 6 is equal to 0. So, let us locate these points in the graphical plan. Now you see 0, 2. So, this point is 0 and 2. This point is 0. So, x coordinate is 0 and y coordinate is 2. So, 3, 1. Now you see 3, 1. This is 3, your x3, y1. Minus 3, minus, plus 3. So, you see minus 3 plus this point. Minus 6, 4. Minus 6 and 4. So, we got at 1, 2, 3, 4 points. So, we got a straight line. Similarly, come to the second equation. The 2x minus 3y minus 12 is equal to 0. A pair consisting of two equations, two linear equations. Now see, by transposition, we get 3y is equal to 2x minus 12, y is equal to 2x minus 12 by 3. So, accordingly, we prepare the table of the value of x and y. So, x3 minus 2, 0, minus 4, 6, 0, minus 3, minus 6. So, please be careful. We need 3 points, and you can find out 3, 4 or 5 points. It doesn't matter. Okay. Now locate these points or these coordinates, x coordinate and y coordinate, in the graphical plan. Okay. Now you see 3 minus 2. So here is plot x coordinate 3 minus this point. 0 minus 4. Here 0 and then minus 4. 6, 0. So x coordinate 6 and the point lies on the x axis. So y is equal to 0. Minus 3, minus 6. Now you see minus 3 and minus 6. Now let us join the 4 points. Now we observe two straight lines, and two straight lines intersect at a point, and that point indicates two coordinates, x coordinate, here x is 6 and y is 0. That is the solution of these pair of linear equations. So our observations were noted here. Intersecting lines. Now you see two lines, the intersect at a point. That point is described by two coordinates, that is x coordinate and y coordinate. They are consistent pair. The two pairs are consistent, means they have exactly one solution. They have exactly one solution, and that is unique solution. Here we got the solution x is equal to 6 and y is equal to 0. So when we compare the coefficients of x and y, what do we observe? You see, so here coefficient of x is 1, here coefficient of x is 1, here coefficient of x is 2. So a1 by a2 half. Now come to the b1, that is 3 by minus 3. You see 3 by minus 3. So it is a1 by a2 half and b1 b2. b1, the ratio of b1 and b2 minus 1. Now compare the ratio of a1 a2 and b1 b2. They are not equal. Now you see, this is the important point. It reflects that, or it shows that, it indicates that the two lines are intersecting and they have exactly one solution and unique solution, and two pairs are called consistent pair. Okay. Now this concept, that is the graph number 1, is clear. Next come to the second case. Now we have taken a pair of linear equations, the equation number 1 and equation number 2. The first equation, 2x minus 2, 2x minus 2y minus 2 is equal to 0. By transposition, y is equal to 2x minus 2y 2. Similarly, we got the value of x and y in a table, and we prepared a table, and we put the value in a table for x2, y1, x4, y3, x0, y minus 1, x minus 2, y minus 3. And now locate these points in the graph. Okay, in the graph you locate now 2, 1. For it, here 2 and 1, this point. Then 4, 3. Here 4 and here 3, this point. 0, 1. So here is 0. Sorry, here is 0 minus 1. 0 and minus 1, this point. And minus 2, minus 3. That is minus 2, and this is minus 2. Sorry, this is minus 2 and minus 3, minus 2 and minus 3. Now let us join. So we got a straight line. Similarly, for the next table, that is 2x minus 2y minus 1 equal to 0. So let me explain. Y is equal to, by transposition, y is equal to 2x minus 1 by 2. So here the values of x and y are, that have been reflected in the table, x1, y half, x0, y minus half, x2, y 3 by 2, or 2 full 1, not 2 full half, or 2.5. Here x minus 2, that is minus 5 by 2, that is 2.5, or 2 full half. Okay. So these are the values of x, y reflected in this table. Now let us locate these points. So x1 and y half. So you see this point is this point 1 and half, and 0 minus half, and this point 0 minus half. The 2, 3 by 2, 2, 2, 3 by 2. Now see this point 2, this is 3 by 2, 1.5. Next, minus 2, minus 5. Here minus 2, here this point minus 2, minus 2 half, that is minus 5 point, minus 5 by 2, or minus 2 half. Okay, so let us join these points. Now we got two straight lines. So two straight lines, they are parallel, means the straight lines are endless and they cannot meet even at infinity. So parallel lines are endless. So the two pairs, the two lines, or a pair of lines, are called parallel pair. This is called parallel lines or parallel pair. inconsistent pair because the two lines they don't intersect. So inconsistent pair. And since they don't intersect, they don't have solution, no solution. In case of parallel lines, there is no possibility of intersecting two lines. They can't intersect. So this is called inconsistent pair and they have no solution. And let us compare. Now let us compare their coefficients. So now you see 2 by 2. 2 by 2, that is A1 by A2, the ratio of the A1 by A2 is 1. Similarly, the ratio of B1 by B2, B1 by B2 minus 2 by minus 2 is 1. This is 1 and this is 1. Now, the ratio of C1 by C2, now you see minus 2 by minus 1. This is minus 2 by minus 1. This is 2. Now you see what we got. What formula we got? A1 by A2, the ratio of A1 by A2, this is the coefficient of x and this is the coefficient of x of second equation is equal to B1 by B2 and is not equal to C1 by C2. And if this is the condition, then two lines will be inconsistent pair. Two lines will be parallel lines. They cannot intersect and they don't have solution. So come to our third case. So we have taken a pair of linear equations x plus y minus 5 equals 0. So y is equal to 5 minus x by transposition. So we have got the values of x and y. We have noted on a table. So x0, y5, x1, y4, x minus 1, y6, x2, and y3. So now let us place these points. And first is actually 0, 5. And here is 0 and this is 5. First case. You see 1, 4. Here is 1 and here is 4. Second case. And minus 1, minus 6. Here minus 1, minus 6. This point we have already noted. 2, 3. Here plus 2 and plus this point. You see. Now join this. Join these lines. So we got a straight line. Come to the second equation. In the second equation, we find by transposition 2y is equal to 10 minus 2x, y is equal to 10 minus 2x by 2. And we got the values of x and y that we have reflected on a table 1, 4, 2, 3, minus 1, 6, 0, 5. So let us locate all these points. So now see 1, 4. This is 1 and this is 1 and this is 4. This is already taken. Then 2, 3. The 2, 3, this point we have already taken. Now see minus 1, 6. This is minus 1, 6. We have already taken this point. And 0, 5. This is 0 and this is 5. So all these points, now you join them, you connect them, join them, connect these points. So we get the line, two lines are coincident, overlapping each other. Now see, so line AB and CD, the two lines, they are coincident. So what do we observe here? The two lines are coincident lines and one depend the other. That's called dependent pair. Dependent pair, and each and every point on the line has two coordinates. So x and y. So each and every point has two coordinates, two values x and y. So up to infinity, the two lines, the two ends are endless. So we can get infinitely many distinct solutions. So when the two lines are coincident or overlapping each other and every point is common to both the lines, then it has the a pair of linear equation has infinitely many distinct solutions. So, what is the formula that we get here? Now, you see, let us compare the coefficient, the ratio of A1 and A2, they have, now you see, 1 by 2 half, and ratio of B1 and B2, they also have 1 by 2, and ratio of C1 by C2, C1 minus 5 and minus 10 here, C1 by C2 also have. Now we got A1 by A2, B1 by B2 is equal to C1 by C2. In this case, if this is the condition, then we can say the two lines are dependent pair, and the dependent pair, two lines are coincident pair, and the two equations, the pair of linear equations, have infinitely many solutions or many distinct solutions. So our conclusion, we conclude whenever A1 by A2 is not equal to B1 B2, that is called consistent pair or intersecting line, and we have unique solution. Actually, they have unique solution. They have exactly one solution. And when two lines are parallel, they don't intersect. They are called inconsistent pair, and they don't have any solution. So the condition is here, the ratio of A1 and A2 is equal to B1 by B2 is not equal to C1 by C2. So this is important. And when two lines overlap each other, coincident, two lines are coincident, they are called coincident lines or dependent pair. So this, in this case, the equation, the pair of linear equations have infinitely many distinct solutions. So the condition is the ratio of A1 by A2 is equal to B1 by B2 is equal to C1 by C2. So these are the formulae or formulas, whatever you call it. These are the formulae that we derived from a pair of linear equations, two variables. In first case intersecting, second case parallel, third case dependent pair coincident. Hope you have understood the basic concept of graphical method of solutions. In our next class, we shall cite some examples how to solve the linear equations by elimination method and substitution method. Please stay tuned to watch our videos, and if you like, you may subscribe or share. Please stay tuned to watch our videos in all subjects, in all subjects starting from class 7 to class 12. Thank you all.